Hello, my name is Ece Velioğlu and I'm a first-year Electrical and Electronics Engineering student at Bilkent University. In this video, I will present my Physics 101 project, where I examined how the string length and the mass of the puck affect the oscillation period on an inclined air table. In this system, the puck behaves similarly to a physical pendulum constrained to move along the surface of an inclined air table. For small angular displacements, the motion can be approximated as simple harmonic motion. The restoring force arises from the gravitational component acting along the incline, which is given by G sin beta, where beta is the inclination angle. This leads to the theoretical expression for the oscillation period, which is the period t is equal to p multiplied by the square root of L divided by G sin beta. This equation establishes two important theoretical predictions. The period should increase proportional to the square root of the string length, and the period should be independent of the mass of the puck. Since mass does not appear in the expression, these predictions form the basis of my experimental investigation. In my setup, the air table was inclined using logs, and a puck was attached to a string whose length varied. A spark timer allowed me to measure the motion precisely, and a protractor was used to determine beta. I first varied the string length while keeping the mass constant, and then varied the mass while keeping the string length fixed. For each configuration, I measured several oscillations and compute the period. My results follow the theoretical expectations closely. First, effect of string length. The graph of T versus L shows a clear increasing trend. As the string length increases, the measured period increases in a manner consistent with square root relationship. When I compared the measured periods with the theoretical predictions, the percentage error remained moderate. The discrepancies can be attributed to several experimental limitations. Small timing uncertainties in identifying spark marks, minor friction due to non-ideal airflow on the air table, slight inconsistencies in the release angle, uncertainty in measuring the exact effective length of the string. Despite this source of error, the overall trend aligned strongly with the theoretical relation between T and L. Then I investigate the effect of mass. The T versus mass graph showed the period remained essentially constant for different masses. The result directly supports the theoretical predictions that the mass should not affect the oscillation period in this system. The slight variations in the measured values are again consistent with the experimental limitations, particularly timing inaccuracies and small changes in the initial displacement angle. However, these variations did not alter the overall physical conclusion. In conclusion, my experiment successfully confirmed the theoretical model of oscillatory motion on an inclined air table. The period increases with the string length, and the period does not depend on the mass of the puck, which was validated by the nearly horizontal graph. Thank you for listening to me.